talk for you. So this Kinsey Frick with Noah is going to talk about an experimental wetted wall that was installed at Bradford Island. And with that, the objectives were two-part. One, to look at lamprey use of that wetted wall structure, and the other part of it was to make sure that we weren't having any salmonid interactions. So with that, I'll let Kinsey get into the details.
Thanks to everyone who's still here for the last talk of the day before lunch. I've got some videos, so hopefully you can stay awake for those. They're kind of fun. Like was just said, the goal of the study was to consult on design and installation of a wetted wall in the Bradford Island fishway at Bonneville, and then to assess adult lamprey use of that structure, behavior, possible risks to migrating salmonids interacting with the wall, and then the end results for tagged fish that might have used the wall. We've heard a lot about how lamprey don't do well passing through the serpentine weir section of the fishways. So the wall that we designed and installed and evaluated is meant to give them an option to get out of that serpentine weir section and into the adjacent auxiliary water supply channel where a traditional LPS is located without having to turn around and go back down past the count window and find the AWS from another route. So the wetted wall was installed in the section just upstream of the count window at Bradford Island and downstream of the serpentine weirs that were just being discussed in the last talk. And again, it allows fish to pass from this section of the fishway over this short wall and into the auxiliary water supply channel where there's a lamprey passage structure. This structure is based on an experimental structure that we tested in the fall at Bonneville in 2014. The structure that was installed at Bradford Island had some modifications based on the results of those experiments, such that water was supplied through a sidewelling structure at the top of the structure, and we put a hood on it to prevent predation and provide some cover from light, a longer transition pan at the top so that longer lamprey had an easier time using their bodies to swim through the exit. A pit antenna was installed at that exit, and we used video cameras to assess the structure. This was fabricated and installed by Corps of Engineers. So the structure they built was really pretty. It was based on a design process that we consulted on. It was finished just prior to installation during the winter of 2018. There's not really an opportunity to put water on this kind of a structure before it gets installed. So just before it was installed, some changes were made, and then water wasn't added to the structure until after it was installed. As a result, the things that got changed were that there had been perf plate here just prior to the exit that got covered over right at the last minute, and a change to, I think it's on the next one, a change from a flat pan to an angled approach up to this exit. Unfortunately, those changes changed the pressure of water coming through the system such that there was a lot of spray action happening inside that pan. That wasn't exactly as was intended, but we decided that we would see how lamprey dealt with it anyway. So this is what it looks like installed. This was the location of installation. Here's the passage structure on the wall. It's a really sleek structure that doesn't protrude into the fishway at all. And that's actually the great beauty of this design, is that the typical LPSs are a three-dimensional ramp that is attached to the fishway wall. You can't do that sort of a design in the serpentine weir section where there are so many fish at some times of year and really constrained spaces. So the idea here was to provide a passage structure that didn't protrude into the fishway but could still be used by lamprey. Like I said, the basis of our review was video-based. Oh, it is autoplaying. Yay. So we had two views of the camera, one at the exit, which actually is on this last slide. Here we have a video pointed directly at the exit to enumerate lamprey that are exiting the structure, as well as a view from basically this view, from where you're standing over here, looking at the structure across that part of the fishway. So looking at behavior on the wall. And the other thing is that the flow was set really low to try to minimize salmon interactions based on worries that there would be salmon interactions at that wall. So this top video is what the flow level was like early in the season, really low, no splash, but also not really an attractant flow. And then I think something got caught in the pump or some part of the structure, and the flow changed on its own without anyone doing anything on sometime during the night on July 24th. And the result after that was what is viewed down here on this bottom one, which produced a little bit of splash at the water surface for the remainder of the season. We ended up with 3 time periods to review video for. One really early in the season, May 1st to 23rd. Another one during a high lamprey passage time, July 24th to August 8th. And then again, September 3rd through 10th. The video review and the pit detection suffered from, I think, power interruption. So we had a backup power system that would bridge inconsistent power that happens at the dam, but it was not sufficient to cover outages of a couple of hours, and I think the power to that area was cut for work elsewhere a couple of times that resulted in these prolonged outages. So that means that the warm colors, the orange and red, are the times that we had video review, late, middle, and early in the season, and we missed this part of the lamprey run at Bradford. The main data slide here, we counted 343 lamprey using the structure during the 52 days that we reviewed total, and it was 24-hour review day and night. And then in the green bars, so that's in the blue, we counted as many as 44 lamprey passing via that structure on a given night. There were lamprey that passed every night during the time when there were quite a few lamprey in the Bradford Island fishway. And then I calculated what proportion of fish that had been counted at the Bradford window then used the wall. And that was anywhere from like 1% up to 70% of the lamprey that were counted. There's a lot of variability in those counts. There was also a lot of variability in the number of lamprey using the wetted wall. The average percent across the whole time period was 13.3%. Of lamprey that were counted at the window then used the wall. And so I just extrapolated from the window counts what you would expect the number of lamprey to have used the wall to have been based on detecting, or 13.3% of them, of the window counts using the wall. And you would project 3,449 lamprey to have used the wetted wall over the course of the season. Like I said, there's a lot of variability here. It could be less than that. It could be more. As was mentioned earlier, the earlier fish tend to be bigger, a bit more energetic, and we missed that portion of the run here early in the season. All but one of the lamprey that passed using the wall passed at night. So if you're at the dam and you see this thing and you're like, no fish are ever using that thing. You're there during the day, that's why. The one that passed during the day passed at 7 o'clock at night, so it was only marginally a daytime passage anyway. And so that's the one daytime passage in the top video. The lower video shows a time when there were 3 or 4 lamprey on the wetted wall all at once. We did have numerous instances where there were multiple lamprey using the wall simultaneously. Sometimes they knock each other off. Mostly they're successful when it's on the order of 3 or 4 fish on the wall, and we never had more than that, really. The average time that it took to pass the structure completely was really quick, 2 minutes, 21 seconds from when it first attached to the wall above the surface of the water to exit into the auxiliary water supply channel. The max amount of time taken was just over an hour. And that was fairly evenly divided on average between time on the vertical portion and time up in the pan. As with all of the structures that we've evaluated, there are instances of multiple attempts needed before a success. We counted a total over the course of the season of 91 fallbacks off of either out of the top or off of the wall itself. Most of those are out of the top. This poor fish is the one that had 28 attempts. That's its first one. Kept going up the wall, attaching, let going of this part, attaching to the hood, and then falling back into the fishway. 28 times. Likely the same fish. It's a little hard to tell, but they happened over the course of just a couple of hours. And then it seemed like that same fish did finally pass. We also had instances where they would come up on the wall and then fall off. That was less common than falling out of the, off the top, basically at the crest where you transition, where they have to transition from vertical to horizontal. And then, as Nathan was saying, you see a lot of interesting behavior on exiting. So we did see fish that would flip themselves around as they exited the structure, attach onto the back plate, and then fall into the AWS. They never spent more than about 15 seconds attached there. They have water the whole time. They ended up where we wanted them to be. But you could eliminate that behavior by just adding some perf plate to that back part so that they can't attach. We detected 3 of the pit-tagged fish that Matt talked about early in this session that University of Idaho tagged using the wetted wall structure. One of those was a double-tagged pit radio-tagged fish. The other 2 were pit-only. 2 of those moved through the AWS, found the LPS at Bradford Island, and exited out from that structure. The other one's last detection was at the wetted wall structure, and then it wasn't detected again. But clearly that's a really small number of fish to draw any large conclusions on about how well fish who use this structure do in the grand scheme of things. It ends up being one single line on this slide, but over the course of video review, we reviewed all of the daytime video that we had. We saw, and the nighttime video, but we saw 0 interactions by salmonids of any type or any other species that might be using the fishway with the wetted wall, regardless of whether it was on the low flow setting or that spontaneous sort of moderate flow setting that created some splash in the fishway. So that's a huge positive result from this because it can help alleviate the worry that you might have negative interactions by salmon with this kind of structure in the fishway. We also did not see any observations of predation attempts by birds or anything on fish that are using the structure. So the bottom line, lamprey did find the wetted wall, use it to pass from the serpentine weir section into the AWS. They navigated that structure quickly. They did key in on the splash. This video just shows, I don't know if that one's going to play or if it already did, shows what it might look like as they approach the structure underwater. This is video from the experimental structure in the furl. Since lamprey will basically climb anything that's wet, they didn't just use the squared off structure. You did see them trying to climb a bit on the concrete that was adjacent to the structure that was wetted by the water coming off of the wetted wall. You know, in future applications that could be made into more of a fan so that that was all smooth and they could just, as they went up the fan, hit some barrier that kept them from going vertical but funneled them towards whatever available passage route there was. And clearly we need to work on alternative power supplies to help with the prolonged outages that resulted from power being cut to that area and affecting our ability to record video. And this took a lot of people, not everyone mentioned here, to help with the the design of the monitoring equipment and downloads and all of it, so thanks. We did see a lot of this kind of behavior in the video of lamprey free swimming in that section of the fishway at night, which you can only see with this infrared camera type video, so that was pretty cool. We see them moving along the wall and stuff too. Happy to take any questions.
Thanks, Kinsey. Let's see, any questions for Kinsey?
Yes, everyone's ready for lunch. Nathan has a question.
Sorry to be the only person asking questions. I'm sure they're just in awe. Research that's being presented right here. So my concern with lamprey is trying to account for which ones are going where and coming and going. And I appreciate the fact that you had a lot of difficulties collecting information there. It looked like you've tried to take the average percent of fish using this versus coming through the window, it sounded like, to extrapolate to what is possible passage through this structure. Have you looked at the correlation of fish use of the wedded wall and fish coming through the window? Like, how do you justify using that as a correlate?
Clearly, it's not, there's a lot of variability, so it's not 13.3% every day of the window count that we then saw use the wedded wall. So I had to use an average. There's a lot of variability. And it's not always that, like, on a low window count day, you get sort of an extreme percentage use. So if you only counted 20 at the window and then we had 8 pass the wedded wall, like, it's not that. Some large window count days we also had low passage or vice versa, high passage. So it's a math extrapolation that's clearly imperfect.
So I was just wondering if there might be a way to do it a little more in a nuanced fashion, looking at smaller time blocks, for example, or just looking at a linear regression, seeing how high the correlation is, if there is one, and then maybe applying that over smaller periods of time, just to, you know, so you're not using some average over this huge range. I don't know. Thank you.
Last chance. Thank you, Kinsey.
Thank you, Kinsey, and thank you to all of our presenters the last couple of days. Great presentations, and also I think everyone recognizes this, but there's the presentations we see are just the tip of the iceberg relative to the amount of work that went into these studies. So let's hear it for everyone and their teams for the great work that they did this year. And then lastly, we will attempt to get these presentations posted in the coming weeks. We did take video. That's a little more challenging. It's a little easier to get the slides together, so please be looking for that. All right, thank you, everyone. See you next year.